x equals y plus 2 times ln of 3y plus 4. What are the gradients at P and Q, where P is where it cuts the x-axis, Q is where it cuts the y-axis? Okay, interesting little question. Let's see what we can do with it. Let's find P and Q first, shall we? Well, for P, that's going to happen where it cuts the x-axis. That's when y equals 0. So you've got x equals 2 times ln 4. Fair? Anything else I can do with that? I'll tell you what, just for fun, I could write that as 4 squared, which is ln 16. It's not really a big deal. You could write it either way. I'm not sure if one's more simple than the other, really. But that is ln 16. Q. Well, that's when x equals 0. When x equals 0, we have basically the whole equation on the right-hand side, not much changing. It's already factorized for us, though. Ln of 3y plus 4. So either you can have that equals 0, or you can have this equals 0. Yeah, I mean here basically is going to say y equals minus 2. Fair enough. Now to get ln 1, ln of that equals 0 is possible actually. You could have, yeah, let's try and solve it. Ln of 3y plus 4, or it seems like it would be possible, equals 0 because you could do e to both sides, and that would be 3y plus 4 equals 1, which means 3y equals minus 3, which means y equals minus 1. I guess the only thing with that, you just want to check, would it definitely work? But yeah, your problem's going to be summing it back in, isn't it? Because if you put in minus 2 here, you're going to get a negative inside the log, because you'll have minus 6 plus 4, which is actually minus 2 going into a log, when you're not allowed to put a negative inside a log. It doesn't matter that, y is negative. That's not the issue. The issue is when you sub it back into a log, the thing going in, overall in the log can't be negative, and here it would be. So the y equals minus 2 is gone. That's the only answer left. That's minus 1. Cool. Now then, we need gradients. Gradients means differentiation. Let's just rub this out a little bit. We know that y equals minus 1 is the answer. Let's rewrite it. And let's differentiate. You could try and get that as y equals, or you could do, I guess you could do dx by dy and then flip it. Is that probably the easiest thing? I think so. So let's do dx by dy. And it's product rule. So product rule would be differentiate the first thing. Just goes to 1 times ln of 3y plus 4 plus, keep the first thing the same and differentiate the second thing. That's going to differentiate to 1 over 3y plus 4 times the derivative of what's inside the ln. 3y plus 4 differentiates to 3. So it should look like that. Pretty good. Now we just need to find the gradients. Well, we need the y coordinates of both of them, don't we? I'll tell you what, p is easier because for p, y equals 0, right? So y equals 0 for p. So that means dx by dy equals what? Ln 4 plus what we got here, 6 over 4. So is that right? Yeah, 6 over 4. So I guess what you could then say is that dy by dx is 1 over ln 4 plus 3 over 2. And if you didn't like that fraction, you could times top and bottom by 2 and just say 2 over, well, again, you got 2 ln 4, which is ln 16 again. It's just one extra step of working there. You see, when you times that 2, you're just going to get ln 16. So that would be the exact value gradient at P. Let's do the same thing for Q. Just subbing in. So that was y equals 0. What about at Q? You got y equals 1. minus 1. What about at q? You got y equals minus 1. Subbing it into the same place, you should get that dx by dy is, well actually that's going to go to 0, because you're going to get 4 minus 3 is 0. So all the fun's really happening in this part. You'll get 1 times 3 is 3, 3 over 1. So I think that's just 3. You can check that yourself if you want, but subbing it back in, to me, dx by dy is 3, dy by dx is a third. Turbo recap. There's an equation. It's given as x equals. What are the gradients in exact form at p and q? Well, let's find p and q first. It's where they cut the axis. Good to always remember for any solving. Cuts the x-axis when y is 0, cuts the y-axis when x equals 0. Here y equals 0 is just a subbing in situation, which is reasonably okay. Ended up 2 times ln 4. You don't have to write it as ln 16, that's just depends how you're feeling on that day in history. X equals 0, a little bit trickier because there are 2 possible answers and you do need to, I guess visually from the graph you can see that one of them is going to go, but how would you? That's going to go. And why? Because when you sub it back into the original equation, you get a problem. You get a minus going into the log and that's not allowed. That doesn't happen here. When you put minus 1 back in, you get all positive stuff on the right hand side. So that's good. Then you're ready to differentiate it. That's product rule. By the way, you're doing dx by dy. Don't be afraid to do that because you can always flip it afterwards. So that's what we've done. dx by dy with product rule and then subbed in our y coordinates for p and q and flipped them. This one had a couple lines of working to get to 2 over ln 16 plus 3. This one had sort of fewer lines of working, mostly because the log just went away when you put in minus 1. Save that for your revision. Subscribe and more videos are coming regularly as we build up to exams. Give the video a like if you enjoyed it. Happy day and happy maths. There you go. That's the slogan for you. Bye guys.